Alright, let's get started. First thing, we need to get a better image here. I'm going to see what I can do. Higher quality image of the parts. Probably should have done this with a photo, and maybe it's not even going to be possible. Should I even worry about it? I just want to be able to see what we're planning. I should go straight for a full screen on the webcam. Let's say Zoom cam. Here, I'm coming back. Hold on. That one, and then Logitech webcam. Right in the center. Cool. So all we're looking at here is just getting out the parts, get a better screenshot of everything that we're going to be doing. Because we made a good start last week. In the first stream, we got 6 or 7 parts done. I want to keep that momentum up by having a really clear picture of what we're going to do session by session. We've got 2 hours plus tonight. I think we'll get a lot done. Add in this one. It's working on a high resolution image compared to last week's part grouping. And if I can't do it here, I'll just get my phone out and get a nice picture. So I did those. And then all of these side. Yellow. And black, yellow, yellow. I think I'll do it separately. Okay, don't worry about that. Don't worry about those. I'm missing one part. We'll find it later. Let's get started on some modeling. We've done, what shapes do we have here? Yep. Cool. So we've already done this. We've done these parts here. We've done this part. We've done these. We're going to jump into the gears. Let's just get straight into SolidWorks, hey? All right, next up, we're going to model these 4 parts. Some of these trickier than others. This one quite small. It's not going to take much to get that one done. The gear is actually going to have a fair bit of detail, so that'll be quite interesting to measure. This black one, again, quite small, but some little detail in the side that you can see. So I think we'll probably do that one last. Let's get the yellow one done first, and then move on to the gears. Okay, so this part, I can't zoom in any more than that. The camera is going to be too small. Let's have a look at what part it is. We can see it here. It is a yellow Technic Bush. Let me zoom in on this. Okay, yellow Technic Bush, half smooth. If we have a look at the 3D of this page, so back on BrinkLink, it gives us a bit of an idea about the part, what it looks like. This is a nice detailed shot, this photo. Doesn't want to load though. User image. Yeah, you can see it's got a shape that's going to match the axles that we did last week. It's got some small fillets, radius. Let's do this with a revolve. So I'm going to start new part. And on the front plane, just have a look here. And we get it in zoom, in focus. It's very difficult. Let's measure that on the outside. So when we do a revolve, it means that if we want to use the front plane, then, or if we want it facing the front, we actually need to do the revolve on the top. Because we're doing a section. So I get a diameter. It's 7.4. And I'm going to start with a construction line in the middle. And then my shape is going to come out here to the side. Okay, so to do our 7.4, grab our dimension tool, hit the outside of the shape, construction line in the middle, and move the cursor to the left to get a diameter. Everything will scale down with your first sketch. Right. Then next up, we can look at the height, the depth. Okay, so measuring that way is right on 4 millimeters. So 4 for this one. Now the inner shape, there's 2 ways to do this. You can look to the wider opening and then say we're going to add material, or go to the small opening and cut away. I think we'll go to the wider opening, which means I'm looking at the width that's across here. So just put calipers in there, measure side to side. I'm getting very close to 5, so I'm going to say it's 4.8 millimeters, which matches with the axle size. So 4.8. And now we can add some additional detail on the outside. So if we have a look in that section view, you can see it's got that sort of dip in the middle. If we think that's symmetrical, which it is, that means we put that semicircle cut right in the middle. Now that's nearly impossible to measure given how small it is. I can't even get the focus, right? But I might be able to measure the width either side. Probably not on camera, but it's very close to 1 millimeter. And I can try and measure the width across the middle using the sharp points of the calipers. So at like the smallest point right through there. That's measuring around 5.8 millimeters. So what we can do, the circle like this, I'm going to grab the inside edge of that circle, diameter across 5.8. I'm going to make sure that this is in line with the middle. So I'm going to right click here, midpoint, put those in line. And then I said before, I think this is about 1 millimeter here. So I'm going to use my trim tool, cut away the middle, make that 1, and that works out the radius for me. Now, what this doesn't measure is the exact center point of that origin. This looks pretty close. I'm going to be pretty happy with that shape. Later, we'll put a little fillet on these edges here, or I could do that now. They're too small to measure, so we'll do that by eye, and let's suggest that they are 0.5 of a millimeter, maybe less, 0.3. Okay, I'll go features, revolve, and that is the start of our shape. Now let's just have a look how that profile looks to the part. It's reasonable. Let's go ahead and save it. Technic Bush. And the part number 4265. 65. Technic Bush. Half smooth dash yellow. All right. Now the inner shape. We can do that in a similar way to how we've done the axles before. So you see it's got the cross through it. If I just bring that up a bit bigger. So it's not like a square cross, it's actually got like a rounded curve to each of the edges. So when we model, we can use the front face here and do a we're going to convert that edge and then draw 2 lines. We're going to make those equal. And then I'm going to select those and do a circular sketch pattern to make 4 of them. I make sure that that central point there is tied to the origin, and then we can dimension them. I expect it's going to be very similar to the axle. So the gap in between is quite small. I'm getting 1.9 millimeter. All right, that fully defines that sketch. Now, if I Control Tab over here and we have a look at one of these, see that is 1.8. So this makes sense that there's a little bit of clearance. even if there's not clearance on the outside edge. Good morning, Hugo. Thanks for stopping by. Nighttime here, but hope you're doing well. Okay, so let's extrude that through. Any like radius on the inside faces of that part. Again, I can't quite get the zoom detail. There's probably some very small fillets on those edges. We might put those in. Let's say like 0.2 of a millimeter. Like that. Just make sure this stays fully defined. Just dragging those edges out to the circle. All right, like that. So I put some radiuses on these edges. And then we do extrude. I have to select contours. Select these four. I'm coming up to this face. It's all merged in. All right, going to tweak something quickly. I'll make this along the very bottom. This is the area I can cut out of the recordings later. Cool, that's better. All right, next detail with this part. Let's have a look. It's got a very small ring. I don't know if we're able to see it. Only if that camera will autofocus. And I don't believe the CAD or the screenshots of the part show it. Unfortunately, I can't get it there. If we have a look over here, let's open up this part. You cannot see it here. Doesn't show. But if we look at these images, pardon me, you can see this edge, this white edge here around it. So that's raised, which means on the very thickness of the outside thickness of part's 4, but at the very top it's like maybe 0.2 millimeters less. All right, so there's a small ring where it just cuts in a little bit before there's an outside radius. Right, so on this, what that looks like is probably where we would change the revolve. Would be one way of doing it, or you can do a cut. I might do a cut in this just to show a different process. So I'm measuring that at like a 6 millimeter diameter. So I'm going to put a 6 millimeter circle in. Now I'm going to do an extrude cut, flip side to cut, 0.1 of a millimeter, like that. half a millimeter thickness. Actually, I didn't even need that. It's just cutting everything. And I can't, because I didn't put this midpoint on the origin, I can't mirror it just like that. But we can change that by moving this sketch to make that in the middle. And then I can try and use this cut. And it's going to be the front plane. Yep. New features, mirror. And now I've got that little lip on both sides. It's very small, but it's there. All right, any other detail to this part? It's probably got a very tiny radius on this edge. Let's put that in, 0.2, or even less, 0.1. Nice and clear. And color, I'm going to get the yellow color. I had a really good tip from a viewer from last week. So let's go to that tip, because I want to, of course, share anything with you guys that I'm picking up along the way. Now, I did not prepare earlier, excuse me, but we will find that. All right, this is from Peregrine. For color accuracy, if you select the eyedropper inside SolidWorks, hold down a left mouse button and drag the tool outside SolidWorks window over a color on a website, that will select the color for SolidWorks and tell you the RGB value. So how that can work, if we come to here, let's try and see if we can find information that we need on the colors. Can't quite remember where it is. Color guide. This is a yellow part. We have a rough color here. Color variant 3, color ID 3. I'm not sure if this is going to give us like an accurate value if we just color match by trying to click and drag onto this. Let's see if we have an RGB listing of Lego colors. That's exactly what we're looking at. Let's just have a look at some of these top options. So there's RGB codes on Rebrickable, all the current Lego colors, hex and RGB codes. No. I'm just going to give us more detail, Lego website. No. Copy the color chart. Sure, why not? Please give me the chart. All right, let's get that through. And here it is. All right, we can assume that this is the 44TR yellow, which is here. Get rid of the rest of these. And the number that we see at the bottom is the RGB, 247.209.18. Now let's go back to the live tip that I got. And to do this, I'm just going to put one of these over on the side. So all right, so to pick a color, let's first just grab a random plastic, medium gloss, and dark gray, put it on the part, right? So I've applied that appearance to the part, or that material with the appearance. To change the color, I'm going to edit the material. I'm going to select the eyedropper, which is here. So I'm holding it. So I don't just click on the eyedropper, right? You click on it, it goes away very quickly. You can see if I click and drag to any color sort of here, or down even on like my screen, down here, I'm getting different colors. So I click the eyedropper, drag outside SolidWorks, over a color or website, that will select the color for SolidWorks. Okay, so all I have to do is, I've got just off screen here, I've got my yellow color. I'm going to click and hold that dropper and move it over to the left, and I'm going to drop it on the yellow. Voila! What a fantastic tip, that works. And you see the numbers it's picked up, 247.209.18. Perfect. Peregrine, that was brilliant. Thank you very much. All right, one part done. Let's insert that into our assembly, just so we've got all the parts here as we go. And while we're at it, why don't we update the colors of the other parts? Not a bad idea. Let's go back to the catalog. So some of the parts here, we can see on that one, don't need that. So this part, have a color info. I think it says tan. Yep, tan. I'm just trying to find that tan color. And it doesn't have the tan on the listing. It's unfortunate. Let's, maybe it's going to be cool yellow. Not perfect, but let's say it's going to be this. Now to copy materials, I can just, copy appearance, paste appearance to get those two to be the same. That one's done. What other parts do we do? Light bluish grey, Technic pin. Now, is that color in this color chart? No. It's not. So it's another one that's missing. We might have to do some more hunting for the colors to get them all right. Let's have a look at that a little bit later. All right, so the part we just did, yellow Technic Bush. That one's done. On to our next part. Next part being the gears. Let's jump into the difficult one. Can we get, there we go. Right, so this part here, this is the light bluish grey Technic gear worm screw long axle opening type 2. Interesting. So this is what the part looks like in detail. There's no 3D for this, not surprised. The image, it's okay. It fits. It fits an axle through it, but pretty loosely. It's not tight as I'd expect something else might be. Not like this one, this gear here. This one's a tight fit. It's not gonna, it doesn't slide around. This one, it's gonna drop off. So different internal detail. The worm gear itself, though, going to be quite interesting to try and replicate. Let's jump in with new part. So a bit of a plan for this. We'll be able to measure a height. It's obviously not symmetrical, but I feel like it's there's a line that goes up the middle of the part. You can see it here, this line. And where the ends, the spiral ends are, this one ends towards this point. And if I flip this around, this one's ending towards this point. So to me, it says the spiral like does a 180 from start to finish. The top's actually like kind of cut off. So I expect that detail on the very, I'm gonna have to get a better camera, I think. Detail around the top edge, that's going to be tricky to do to replicate perfectly, but we'll give it a go. All right, let's jump in. First thing with this kind of part, probably just want to set like some approximate dimensions. Now let's do this from the top. Let's grab a circle and let's get an outer diameter. And so it's right on like 10 millimeters or just under. I wouldn't be surprised if it's 9.8. Yep, 9.8. And then the size, we'll come back and do the size later, but the full height is around 15.6. Okay. So that one there, 9.8 on the front plane. We'll do one that goes straight up, and that's going to be 15.6. So we're just using some simple construction geometry to get going. Hello, Metab. Thanks for stopping by, man. Hope you're doing well. I think I want quality I'm talking about is in these images here. I want to be able to show in a bit higher detail some of these features that are really small. And the zoom, this is a webcam I'm using, the zoom quality isn't perfect for this, so the autofocus. We can do better. We'll get there. Okay, so what we want to do here, there's a couple of different details to this and different steps to it. If you have a look from this view, you can see that there's like a cylinder on the inside that goes all the way up the middle that's consistent. I'm not sure if we're going to be able to measure it accurately, but that bit's consistent, and you do that first, and then we add the spiral afterwards. And the spiral is going to be done with a helix and then a sweep. Let's do that inner part first. And try and measure that diameter. Now it's going to be slightly skewed. But it's going to give me a rough idea. Around 7. Just under 7 millimeters. And then the hole, like we can see straight up the middle, that's it. That's a straight surface with a rib, like that triangle extra that goes all the way through. That's close enough to 5, 4.9 again. 4.9. So we'll do that on the top plane. 4.9, and I said 7. We're going to extrude that up to the top of this. This is the vertex. We're using the sketch. Okay, so just do those sketches again. So 4.9, 7, extrude up to vertex. Okay. All right, so that's the inside of the part. Now we can work on the profile and the path that we're going to use for the sweep. So in this one, let's do the path first. Now, what's interesting is, like, you look at this part and you can see the hexagon, like the swept path starts down at the very bottom and goes all the way to the top. But when you're modeling it, you might want to actually start the path below it and finish it above. To get the detail right. We'll see if we need to do that or not. To count how we're going to do this sweep, what we want to try and find is like an axis that goes, I don't know if an axis is the right word. We basically want to get from bottom to top a measurement. Come on, focus. Camera doesn't focus. If I put that out of the way. One, two, three, four, 5. Right, so it's going around 5 times. And then I'm going to measure the pitch in between them. because we can measure that, even though it's going to be by eye, we can go from edge to edge. Then we know the pitch. The pitch is the distance between. We know how many there are. The height can be worked out for the spiral. So let's use this circle that we've got here. And we'll work out a starting point. We go helix and spiral. Now, first thing is it's going the other direction, right? Can be difficult to see in the preview, but instead of going clockwise, this goes up, counterclockwise. Now we can say the starting angle is 0. The starting angle is here, right? And the angle is relative to, is it going to be the right plane or the front plane? Let's just turn that on so we can see. It's going to be the right plane. So that's showing circle, sketch, helix and curve, counterclockwise, start angle 0. 0 is on the right plane. All right, so it's going the right direction. Now if we assume 0 is on this side over here, and this goes around, we can count. 1, 2, 3, 4, and then it goes up. See that another way? You can look at this edge here. 1, 2, so it's 0, 1, 2, 3, 4, finishes at 5. Put that in, 5, but we change the pitch. The pitch is the distance between them. So I'm going to measure center to center. Now this is not perfect, but it's going to be close enough. It's under, it's right on 3. It's right on or just under 3. So I change that pitch to 3. And then we can see how our helix looks. Starting here, goes up, finishes there as well. Because we're doing 5 revolutions. But in reality, it might actually be 5.5. Because while we're getting a full curve on this side, on the end, is it finishing in the same point? Maybe it is. 1, 2, 3, 4, 5. Actually, it probably is. So that's cool. All right, there is our helix. All right, now to draw the path. Now to draw the profile, not path, the profile. Now the profile should touch this to begin with, but it doesn't need to be exactly on it. I'll come back to that. Give you a bit better explanation in a minute. What we can see is, there's a flat outer face, and then it goes, it's going at an angle both ways. So when I sketch this shape, I hope you're able to understand what I mean when I say that. Now, the right plane is the one that it starts on, so we're going to use the right plane to sketch. And how I'm going to do it is sketch my outer face right on the very edge, like that, and then draw the rest of the shape. Now, this is what we might need to tweak later. All right, we've got that shape, space right. as far as the dimensions for this detail, again, it's very small. So that outer face looks to be between 0.8 and 1. So I'm going to put it at 0.8. And then I don't think there's any way I can accurately measure this angle. What I do is actually just guess that it's going to be 30 degrees. Now that is our profile. Let's see if this will sweep. So I select that path, I select swept boss base, select the profile, and I'm getting it to work. If I press OK, it will merge the bodies. Now we can see our next issue, right? It's going past the top face and the bottom face. So that's the next thing we need to clean up, because here you see it's actually got like a very flat end. It comes around, over, and then gets sliced off. So let's have a look at the options inside the sweep. And the first thing we want to go to is align with end faces. I'm going to press the tick, and that's not making any difference. Next one. We will leave that as is. We're not going to change any of these settings. We'll actually look at some alternative detail. Should we do the bottom first? I think so. So what we can imagine when we're looking at the bottom, focus. Yeah, so it's about where this line is, where our sweep ends, and then it kind of cuts around and is merged in, and that bit's cut off. Now that still follows the circle all the way around. And that's where I wonder if we should actually change our helix to go further than what we're seeing. And there's a few ways we can go about doing that. First is to put a plane above and below. At least it's this sketch here that I want to move down, because that's where the helix is going to start. So I'm going to edit this sketch plane. Now it was one of the first things I sketched, so I've got to move this plane right up to the top. I've got to change it so that this plane is just referencing. All right, we're going to put a plane in. We can do this again. And I'm going to put it offset from the top plane by 1 millimeter down. Move that to the top of my feature tree. I'm going to change the circular sketch on that helix to be on this new plane. So I go edit sketch plane, change it to this one, press OK. And you can see what that's done. That's moved my helix down. All right, so it's now almost going all the way past the bottom. My spiral still has the same inputs. Pitch is the same, revolution's the same. Now I've got a lot more material that passes over the bottom. So now let's continue with this one. We want to get this a little bit lower. I'm going to use the Move Face tool. That's not going to work. I can lower the plane even more. It's going to come down to 1.5. All right, now it's really dropping off. And now the top is not quite there. So what I'm going to do is pitch and revolution. I'm just going to increase the revolutions. It's going to go up to 6 because the pitch is the real driver. So now we can see the result. It's going all the way past the bottom and the top. Then with this, we can do a sketch on the front plane. And what we're going to do is remove the material we don't need. So I'm going to just create a large box, top and bottom. I'm going to use this sketch here as a guide. Might have to change a few things. Hold on. I think the line that we put up the middle here, we need to change that so that it is not on center point of the circle. It's actually on the origin. Let's change this one thing. Right back here. Now I can mirror this sketch around that construction line. Just put some dimensions in to make sure it's always going to be covered. An extruded cut. All right, now we're starting to get the appearance of the part. We have a look here. You see at the very top, it's got that very thin section. Okay, that's just like what we can see here. And as we rotate around, you can see there's a little bit of thickness. It's just like what we can see on our part. And even from the top view, you can see how this sort of curves around a little bit. We're getting a similar thing. Now ours still needs a little bit of refinement. It's not quite right, because in reality, this sort of very thin edge, you'll lose that in the molding. So I wonder if there's a way we can kind of cut that off, but really neatly. Could be something like this. Let's suggest it's maybe 0.3. We do one at the top and the bottom. So I'm just doing a chamfer, and I'm doing a chamfer at a 90-degree angle, which means where this face is horizontal, this ends up with a 90-degree angle on the edge. G'day, Het Patel. Thanks for stopping by, and yeah, thanks for your feedback. Hope you're enjoying it. All right, so we can see that edge. Okay, now I'm getting much closer to this shape. Zoom gonna help us. Nope. Once we've done that chamfer, we can actually put a small fillet in there as well. Now this one needs some text box. So I'm going to put a small fillet here and at the bottom. All right, that's looking pretty similar. Now just to do those pluses through the middle. We'll do that on the top plane. And if we try and have a look at the same orientation of what we've got here, we can see there's one in that bottom left corner and one in the right. We're going to do convert entities. We're going to do that sketch that we've done a few times now, just on one side. Make it equal. Put that radius in. And then we're going to select that and do a circular sketch pattern. We're going to do the 4 points. And we're going to dimension it to 1.9. The thing that we're going to change, or when we select and extrude this, is we're just going to select the just 2 of them. So when we go up to surface, select the contours, we're just going to select 1, 2 like this. And the face will come up to is here. That's how we get that plus. That's how we get those internal shapes. All right, any other detail on this that we think we need? Well, if I feel the edges, I feel like the gear isn't that sharp. Those edges aren't that sharp. So there's probably some small radiuses on those. Definitely through the middle points. So let's put a 0.2 mil fillet around this. I select an edge and an edge. It's probably going to give me a better result. Yep. Do that. Should I do the same thing on the outside? It might be smaller. Select these 2 faces. Select an edge and an edge. That's all right. I think that's about all the detail we need for this worm gear. There is our name, and let's save. 32905. Technic. Gear worm screw. It's the color. Great. Nicely done. Let's insert it into the assembly with the rest of our parts. And what color is it? It's different. It's the same as that. These 2 are the same. Oh. Yeah. Cool. Copy. Paste. Copy. Paste. Very nice. Another one done. Three, 2, 905. Next one, another gear. So small again. Hard to show the detail. Apologize. This one. Let's see. In our list, dark bluish grey Technic Gear 8-tooth with dual face. No 3D. Oh, but this is a pretty good photo. It does say view in 3D. I just don't trust these 3Ds. You can see they're very sharp. Bit rough. Much prefer the images. Like this photo here is, I think, pretty accurate. You can see on this something like the fillets, the edges. So see where, like on this tooth, the gear, there's that white highlight around the edge. Same on these. That's just where they've either been worn a little bit or touched a little bit. It's not a very sharp corner. That one looks a little bit sharp on the right, but yeah, there's a bit of work to them. Now gears. There's probably a bit of technical information out there about gears. What can I say? Done some design work on gears before, but very little over a long period of time, and so yeah, I don't remember all the detail. You're not supposed to remember the detail, you're just supposed to remember where you can get the information or know how to find it. Because with the gears and how they work together, interfacing, was very important for those when you've got like two of them. It's really important that as they like turn, that they turn smoothly. So I think we'll look up some detail about how to create them. Use it as a bit of a guide. Hey, yeah, great question. So Het asks, let me see if I can do this one. Can't get the chat working. Het asks, great question. One question, if you could please answer, what's the most important thing to focus on for long-term growth in CAD? Het. It's a similar thing that I tell a lot of designers now, or engineers, or graduates, work experience. Could be students, younger employees, people in my team. And it's not just CAD related, but it's kind of anything. It's to combine your CAD skills with other strengths, other knowledge. So it's one thing to become really awesome at CAD and be able to do anything and be very efficient. But that's not very useful if you don't know what you're doing. like what you're designing or what you're engineering or what the answers are. Like you might have a specific problem or a part that you're detailing. Let's say it's for a plastic part and you're doing an enclosure design and you need to consider wall thicknesses and fillet placement and size, radiuses, ribs, even could be drafting details. It's combining your CAD skills with the real world knowledge of manufacturing. That's what's going to be really important. And there's a lot of resources now for that real world knowledge, such as like AI, using ChatGPT, using Google to give you the answers you need. You do need to verify them, of course. They're not always 100% correct, but that can, you could ask it for a plastic molding with a wall thickness of 3 millimeters. What should the thickness of my ribs be? And then you input that information in your CAD. So it's about understanding and knowing how to use sort of that outside knowledge and combine that with your CAD skills. So focus on that. All right, let's get into this gear. It's going to be tricky, but it shouldn't stop us. No worries, Head. Thanks for the question. Okay, this gear. What are you doing? Zoom small. Okay. Just notice there is a variation on these gears, just from one face to the other. One face has, I don't know if I'm going to show you in detail here. If you look at these two, these are the same part. But if I flip one over, it's got a very flat face on the internal. Whereas this one's kind of got some lead-ins, so it's a bit smooth as it comes in. Just means that when it's finished, this side will have a bit of different detail to this other side. All right, so I'm just having a look at the detail to get an idea about how I'm going to go about these features for this. Like this internal shape, it's pretty standard. We've done that many times already. Outer gears are a bit different, but they are a pattern. All right, it says 8 gear. It says gear 8 tooth. 1, 2, 3, 4, 5, 6, 7, 8. So there's 9. 1, 2, 3, 4, 6, 7. No, there's 8 teeth, 8 gaps. Yep. So we only need to do one and then pattern them around, right? I think if we start with like the round section, do the inside, and then work on doing one of the teeth, that's a smart way of going about it. And doing it upright like this. Now, yep. Image is too small. We'll get better at that. So let's use front plane. Let's create a circle. I've got this circle outer diameter here. And it's like 5.4. Cool. inner diameter 4 points. It's going to be the same. Oh, 4.8. Going to be 4.8. Yep. And then we've got our usual sort of triangle equal 0.2. We're going to pattern that. Let's just get that on the origin, get the dimension right. It's 1.8. Okay, that is the main shape. Let's extrude that with full width. 7.8. So mid plane. And contours 2, 3, 4, 5. Okay, that is the middle of our gear. Save. I think it's a dark grey. Dark grey. Right, that's inside done. Now for the teeth. Let's see what we can find as far as detail. We've got 8 teeth bit here. Let's see what this tutorial's about. These are basic rules about gears. I don't think it's going to give us the detail on the teeth. I'm not going to get too heavy in it. There's the part that we're looking at. It's a very similar part. Not quite the same. All right, it's not the one we want. Is this going to give me the information I need? I don't know. Here's some information about pitch. You can see the part we did before. All right. There go. Gear, tooth, dimensions, drawing, images. I'm really exposing here my lack of engineering knowledge on gears, because this is the kind of thing that we need to get to. But I'm not a mechanical engineer. I do not fully understand the detail. How much do we want to go into this? What I really want to find is a reference that I can insert see if this works. Okay, spur gear calculator. This is what we need. Number of teeth, 8. Module, oh God, I can't answer these. Gear dimension calculator. Find pitch diameter, gear bank, outer. Calculating gear pitch diameter can be done by dividing the number of teeth on the gearbox diametral pitch. No, come on. I want an easier calculator. I think I've seen this one before. Not quite what I need. All right, ChatGPT, please help. Lego gear. This is how we can use ChatGPT. Let's see if this works. All right, to model a Lego gear with 8 teeth, 8-tooth gear, base your design standard, Lego Technic dimensions. Here's a breakdown of key dimensions. Module is 0.4. Lego gears typically use module 0.4. Defines the size of the teeth and is calculated. As such, outer diameter, slightly larger than the pitch diameter, is approximately 4 millimeters. It's not right. Pitch diameter, key measurements, number of teeth. All right. Some of this is correct. Some of it's a bit off, but that's what ChatGPT gives you. Let's look at the detail. Let's try and work out exactly what the outer diameter is. Let's put some dimensions in first. Let's use the front plane. All right, outer diameter of these gears. Just going to measure 10.6. No, 9.6. The shape or the width at the bottom of one of these, 1.2. This is just setting up a guide, a rough sizing. It's not going to be accurate yet. Does this tooth width at base 0.5? No, that's not right. The OD 8 tooth gear is 9.6 millimeters. Now, update your dimensions. Way too heavy engineering for me. Show me a diagram clearly labeling the gear features. This is fun. What's the chance of this going to be right? Yeah. SolidWorks model help next. Because what I need that shape, that dimension. I don't trust it. Accurately model gear teeth. Toolbox gear components could fit. Getting closer. You know what? That's a good idea. What has McMaster got on this? Does it have gears? Sprockets? Using gear axe. Gear. Can we use metric? Gear module or doesn't have any 8 teeth gears. But what I'm wondering is if I can get something that's going to be close. This is like reference, right? If you haven't seen McMaster before, check this out. Pardon me. Let's have a look. Oh, won't open. Let's try again. Trying to get it to open. Here we go. So here's the gear from McMaster. And they normally build things really accurately. Look at that. All driven by a series of equations. Kind of crazy, yeah? Sketch 2. And then how's it drawn it? Can't. I wonder if we could use this. Yeah, they're using a sketch driven from the equations, let's say, and then pattern it. It's good. Could we use it? Let's just use it as a temporary file. This is a little bit different, but let's see how we go with it. Don't need that. I'm just going to get rid of everything we don't need. Let's see if we can simplify this to a model that is usable as a Lego part, for converting into a Lego part. We can always remodel the detail of the gear later. Not sure it's something that I've got the ability to show in a live stream just yet. We'll see. Get rid of that. So I'm just clearing everything I don't need. Pattern we'll keep. Billets, keep. Cut, yes. Keep that, yes. This one? No. Get rid of that. And all right, are we able now to convert this? What's going on here? Cut, revolve. Get rid of that. Closer. Yeah. Okay. Can we manage it with equations? Number of teeth. 8. Okay. There's an error. We'll see if we can get past it. It's still not quite right. Hub diameter. We were saying we're at 9.6. Which for us would be that top one, OD, 10, pretty close. I think it's the hole in the middle. It's a bit wrong. We've got to remember the Lego's slightly different. Okay, so we got 4.8, 5.4. Now here is where we can just roll up and see how it's been built. So started with a solid block, cut extrude revolve for the middle. Now we want to reduce that size to 4.8. That one is currently the smallest circle there, which is 5, but we can change that. Yep, 4.8. Chamfer. We do not want a chamfer on the inside or the outside, actually. We can delete that feature. Cut extrude. So here it's cutting a tooth. So I get the feeling this is going to be actually reasonably accurate. I don't think we've got that radius there because we have a big cut in between, which you'll see in a second. It's got like a very flat cut. Doesn't have that fillet. It's much less. That's an equation. Let's go manage the equations. We can find that number. So many errors here. Can't see where it's driven. Ton of errors. I want to change this circular pitch by 1.25. Yep, we're not going to do that anymore. This one's just going to be driven by a dimension. That's fine. That's better. That's a lot better. It's even going to be less. 0.1. And then this is where the detail of this one's slightly different. So it's had the edges cut off. And that's what I was showing in this file. 1.2 between sort of point to point. That's where in this cut, you see that's only 0.79. It's much more in ours. So let's get rid of that fillet entirely. Let's go front plane. It's interesting, it's got a flat edge there. This is definitely round. That 5.5. What do we measure for this? 5.4. Let's leave it. So I'm going to convert that. And I'm just going to sketch this shape. Make those both horizontal equal. I can dimension. Yeah, 1.2. I think. Yep. Cut. I'm going to go through all both. Cut extrude. And I'm cut there. We have to change that. In our Lego one, it's not that kind of flat. It is a arc which runs on that face. That looks better. Circular pattern. Pattern needs to include our cut. There we go. It looks extra funny. And why does it look extra funny? Not sure if I can rotate to get the best view of that. Yeah, it's not straight. That's a mistake. I mean, it's an angled cut through. It's a different shape that I need to put it on. So this one here, you have to do it afterwards. Delete it. Just get it out of there. Convert this straight across, back down. This one come to the center. These be parallel. These be equal. Remove this, make this construction. This bit is what becomes 1.2. Is that one right? .4. Move that up to there. And I want to get it in line with, say, like a midpoint of that edge. So right click midpoint, control. Now you can select that. Circular pattern. 8. Cut through all both. Not quite right. Not quite right. Because we need to cut what we're trying to cut off is this little edge. Yeah? But what I can do, let me change the sketch. I'm going to put the sketch onto this face. Then I'm going to do my cut through all. Selected contours. I can select these faces. Now that's better. I've got this little edge down the bottom there, which is a bit funny. I'm going to have to come back and fix that. But now I should be able to do a circular pattern of this. Yep. Like it's getting there. And I have to do that times 8 to fix it. So instead what I'll do, I'll sketch on this face, bring that down, convert this edge. Right, just to fill that tiny gap to surface. All right, progress. This is good progress now. Okay. This gear's extra tricky. Now we've done the teeth. We need to cut away a section. So if we have a look here, you can see that you've only got the full teeth in the middle, and that is the middle kind of 3.8 millimeters. So we're going to get rid of the rest, and it looks like a flat edge. Which is 7.2 millimeters. Oh boy, okay, so front plane. We do a rectangle. I'll explain in a second. I'm going to put a line there. We're going to mirror. No, we're not going to mirror. We're just going to make this parallel. And then this to this. So we said 7.2. This one to here. We're going to make, for construction, make that perpendicular. Get this to that edge. Get this to that edge. Pattern this. Make sure it's on the origin and fully defined. And then the width. Oh, shit. Didn't show any of it. Let's go back. Just did this nice sketch. Let's do it again. So we're going to do a rectangle that comes across here. We're going to do a construction line from the middle to here. We are going to make this, this, and this all parallel. I'm going to dimension that to 7.2 and make that tangent. This is to cut off the top, very top section. explain in a minute. We'll just get the sketch right. Now here, just measure that width, 3.8. So it's 3.8. So what I want to do is do an extruded cut through all offset 3.8 divided by 2, like that. And then I want to do a mirror of that. Now that looks funny because the entire width of the part needs to be reduced to 7.8. I'm going to delete this sketch. Don't think I need it. I need to make this mid-plane. 7.8. Cut revolve. It doesn't even need to be cut revolve. Should just do a circle through there. It's 5 millimeters. 4.8. 4.8. We'll just put it into this. Yeah. I may as well put into this sketch the internal detail. This one. And circular pattern. .8. We just need to update some pattern details, some features, some sketches. It shouldn't take us too long at all. Not to be scared. Box extrude. Just cleaning up of references, breaking references. As we simplify a model, sort of thing happens all the time. So we lose like the reference to up to face, for instance. So you just got to update that detail. This last one here. As you go through, it's less and less. And get rid of all the errors, and then we've got a nice clean model. All right, now, is that part starting to look like our actual part? Let's say yes. Very much yes. Except that the gears are at a different orientation to the X in the middle. It's the only annoying part here. Can I change that? I have to rotate those internal faces 45 degrees, which we can do with a rotate by Z 45. I select the face. But that has to be at 0, that at 0, and I have to select all the faces. It's a bit of a hack. It's not like the cleanest way of modeling it. Now, is that right? Did I go too far? I did go too far. It needs to be that divided by 2. There we go. So now the tooth is properly aligned. See what I mean? You got like the plus signs going up, down, that's the same in line with the tooth. Now I'm going to save this over the top of the other one that I've done. This one. And I'll come back and rebuild it from scratch another time, maybe off stream. But I'll record it and put it in the lesson. Just want to get those sketches right at some point. All right, that is our third one done for today. We've got time for one more. Another gear done. Last one was going to be this small black one. Now that part is this black hinge cylinder. Okay. This part has a axle hole on the end. Very small detail around like this section in the middle. There's an axle hole on the other side. Can't see it here. Quite intricate little details. Let's get into it. Start on the top plane. Do the outside of the part, which measures at 7 millimeters. And I'm going to extrude that up to this section here. It's around 9.6. Line 9.6. And now I can't see how deep it is. The caliper inside goes quite a way through. $10 millimeters. So the depth actually goes like further than this section. Or it's exactly the same. All the way up. I suspect that's it, because what we get with this part is there's this axle and comes in and that goes, you know, deep. If I see how far it goes, it's something like that. This is going up quite a bit. So let's grab that inner detail. Usual sort of thicknesses for the axles. Feels quite loose. So by usual detail, I mean it's like 4.9. And then we've got that corner detail like that. Let's put that over there. Let's do a circular pattern. Something like that. Extrude cut that all the way through. We might tweak a bit more later. Top planes there. All right. On the outside, there's a couple of channels, kind of give it an appearance of in-out, in-out. You can roughly see them there. There's like steps. So I'm just going to measure the diameter of those and put those in. And we'll do that on, like with a revolve cup. So diameter of one of those sections comes down to 6.6, 6.5. Let's say 6.6. So what I'm going to do is put a little section like that. And 6.6. You see it's quite a small difference. And then the thickness at the top, or 1.1 millimeter. And the thickness in between, very small. So that's the same. And then we have 1, 2, 3 of those. And the total section is 7.8 millimeters. So if I put a line here and say that that is 7.8, I'm going to grab this section, do a linear sketch pattern going up. Now I want 3 of these. I don't add a dimension. What that lets me do is use this construction line as the dimension for where that position is. And then I can do a revolve cut. Hello, Jern. Thanks for dropping in. Cut revolve. What are you up to, Jern? Cut revolve creates that detail for us. And then I can keep going with the model. Right, that's pretty neat. Now, what else do we have? So we've got this face, this that extends up the top. This bit is all the way up high, and that it's a flat face. Hard to see. Again, camera detail is not picking it up. That's a flat face across the top. New camera coming for the next stream. Definitely. Flat face there. The full height of this. And on the very top face, it's got a curve. So that face has got a curve. Measure the height. Get to 19.2. What we might do for this bit is just roll back in our model. Okay, so just roll up to here. Going to go on the front plane. Get a sketch. It's going to sit a little bit inside. Like that. I'm going to roughly measure that. .8. How does that work? What's the diameter? 7. Might be a little bit under. But midpoint of that to there, vertical. Those two equal. Height of the whole thing was 19.2. I'm going to say that it's got an arc here. That arc's pretty small. So let's say that arc, it's only, let's say, 0.5 millimeter. And we can go from that bottom face up to the top. Alt Shift, 19.2. And then imagine if we measure some of those corners to where it is at the very top. 5.2. Okay, that's a shape. Not bad. The width of the part, width of the feature, 3.2 millimeters. And I just want to make sure it stays with inside the diameter here, and it's not quite. I wonder if there is a bit of a curve to that part. It's so small, right? Like it can't quite zoom into enough detail. I need a microscope camera. Maybe it does have a bit of a curve to it, which I can put in. So if we left it like this, and then did a sketch on this plane, see how we could do this. Should we use this edge? Yeah, why not? Sketch like this, extrude cut through all, flip side. That's one way of doing it. It's not the neatest. It doesn't really give me the curve on this face. Like if I delete this face, it's going to straighten it right out. That's not what I want either. What I probably want is that yet. I don't want that. I want to work out what that draft angle is to get that face. That is a 5-degree angle. All right, so this is what's going to help me. I'm going to change these to be vertical. 520. I'm going to completely change this part. So we will just extrude it up in a different way. I'm going to convert that edge. I'm going to draw a straight line across either side. Dimension between. Cut that off. Extrude up. Can I do it the way I want to? We'll see. I want to come up to here. I don't want to merge it. That's the important part. Then I'm going to do a thing using contours. I'm going to select that sketch, select this contour. I'm going to go up to surface on both sides. I'm going to merge with this top face. I'm going to delete a couple of faces. So this is a bit quick and nasty, but it works. that one doesn't work. I have to do it in 2 separate steps to get those little edges off. And then I know that it was a 5-degree angle. So I'm going to add draft. Oh dear. I moved too fast. Frustrating. Didn't even save it. Can you believe it? Yeah. Man. Really, really, really annoying that. Super fucking annoying. Okay. Let's just get back to where we were pretty quick. 7.2, 4.9. See what my memory's like. Um, $1.9, extruding up. Yeah, how did I want to go? $9.6. Well, let's save the part before we do anything else. Hinge cylinder 1x2 locking. Hugo. Top part with a revolve, an extrude cut, or is the shape you're looking for different? You could do revolve and extrude cut. Yeah. Yeah, there's definitely a way of doing it. Why don't I do it that way this time around? I'll show you how. I'm sure you probably know, but I'll give it a go. Let me just get back up to that point first. After my crude SolidWorks crash. 1.1. What was this bit? 6.6. That was 1.1. And I have 3 of these. Driven by that revolve cut around here. All right, so let's do a revolve this time. You know what? I think it's a pretty good idea, except the top curve, because the face on the top is not revolved, like it's extruded. So I can do revolve. That's what you can't do. Like if the outside is revolved, then it would work. But yeah, I actually can't. I don't think I can do a revolve for this. It's not the right geometry. The reason I say that, and I apologize that the camera detail is not going to pick it up maybe enough. that this face here, see this one that's kind of got that gloss on it right there, it's got a little bit of curve to it, but it's not circular like everything else. It's quite flat. Right, I can tell because the lighting doesn't match up from face to face. So this bit is circular, this bit is a lot more flat. That's why it's different, and why you got to model them separately, 2 different steps. That's why I was doing a extrude up, and then I was going to draft it, because then my extrude up can have some curve, but the draft is just going to bring it in a little bit. Hopefully I'll be able to explain that as this bit gets done. Let's do it now. So what I was planning on doing was invert this edge, doing a rectangle, trim, dimension. All right, this. So 3.2. And extrude that bit up. Now I didn't do this correctly before, but the total height is like 19.4, and that's from the ground. So put that in, but put in offset from surface and this face, change, and there's my shape. I'm going to uncheck merge. Yeah, that's right, here you go. 5-degree angle, draft, hit that face and that face. Okay. So it's not, even this, I'm not sure if this is right. Like it's close. It's circular there, but is that bit circular? Yeah, it is 2.74. But if I did a revolve, I'm not going to get this line here, I don't think. But like the detail is so small, doing it your method, that would probably work as well. And you'd be hard pressed to notice the difference. What I didn't do on this one was that curved top, but I'll just do that slightly differently now, because there's a few details on this side that I need to put in. So if I look at the front view, I'm not sure if this is going to work out the way that I wanted it to now. Let's see. From that edge to there, like 0.5, that and that equal. That can be 1. Extrude cut through all. That's okay. And then there's this kind of raised detail here. It's actually probably better showing in this image. You see this kind of raised section here. I need to put that in. See this one, when you zoom in, it looks more flat across that edge. Helps a little bit. Yeah, it looks a lot, I don't know, it looks kind of curved, kind of straight. We compare. Not quite there yet. So the other detail I needed to put in was across the middle. That's on this section where I need to convert that edge. I need to have a straight face across from one side to the other. At the bottom, I'll do it from the bottom, 2.5. And then height, I think I've already done the height. 9.8. 9.6. Yeah, how do I do this? Kind of done this slightly the wrong way around. I also think I've got. Just going to check I've got that correct. I don't think I do. That's 7.8, but it's got another gap on the top of 1.1. Yeah. So that shouldn't be there. These are separate. So that to that is 1.1. And then that is 7.8. It's going to look better now. Okay. Sometimes you've got to go backwards a little bit, just up and down the tree to get things right. That's an example here where I knew this. That top face now needs to come down. It's actually this sketch. Let me bring that up. Because now this one actually needs to come down up to this vertex. Flip sides cut. Creating this really weird kind of looking shape. And that's because I said that this was 10 millimeters deep, but I don't think it is. When we put that on, that actually needs to start on this face, like that. And this top section needs to be closed. Yeah. A little bit messy, this, not the most efficient way of doing it. Let's convert these. Let's delete that. Let's delete those. Bring that down. Trim that away. Let's extrude this a millimeter. Let's join them all together now. Okay. Then I can do that angle and cut. So you see it's got like that kind of angle. It's quite severe. The top of it, it's about 1.8 millimeters. At the moment it is 2.5. Best way to do this, let's see if we can draft it. Do all these edges at once. That's about right. That is looking much better. Totally out of order, this one, but that's okay. Front plane, just save. Now it's got that little divot, that little cut there. Not sure if it's actually used for anything. It's tiny. I'm not even sure if it's that. But we can say we're going to go from this face through all. Or we just go sketch plane through all both. But we put it above this. Yep. We put it here. We want to extrude that. Just trying to work out the most efficient way of doing it. This isn't it. Surface through all. And this isn't it because I have to do two separate features to get it to work. It's not quite that big. All right, nearly there. That chamfer hole detail looks a lot like a revolve cut. So we go to this view, and we're on the right plane. We are doing a cut like this, where it's going to have a flat face and then an angle that comes out like this. And it's going to be near impossible to measure those 2 points. The best I can do is maybe measure the diameter of the hole on the outside or on the inside. Do both. And it's like 1.8 on the middle. Like this, 1.8. And on the outside face, 3.2. I don't know the depth. And the height from the top, we can eyeball 2.8. Just turn off the section view for a second, then I can get that edge. And the depth, let's just do something like this. Because what we're going to do is mirror that sketch and then do a revolve cut around here. Last detail is there's that kind of cut on the top. They've got here this sort of angled section. That's because another part sort of fits onto this one. So this is where it helps sometimes to understand how the parts go together. It can help you. So this and this go together. So it kind of pushes on. And it's got a slight ratcheting interference, so it will hold position. So do that slot. That looks like a mid-plane cut extrude. So back to this section here, but separate to the revolve cut that we just did. We will once again do a sketch because we'll mirror it. But this time, let's grab that edge, very much like this. We can measure the top, just how small it is in the middle, 2.8. The angle does not need to be that great at all. Let's drop the angle down to that midpoint there. And last step is how far does that cut go across? It's most of the way. And it's angled, it's like got a draft out. See how it looks at 3.2 mid-plane. That looks pretty good. What would I change on this? Maybe it's going to be more, but it's got a bit of draft. Top plane, and this edge, and this edge, going like that. That's actually much more accurate. And perhaps that is a little bit less. Now, something looks really weird on this. Definitely doesn't look like my dimensions are right. Let's just go through those and check. I'm off by maybe 5 millimeters somewhere, I think. Yeah, it's 14.4, not 19. This one. Yeah, 14.4. That looks a lot better. That's even smaller. That's not quite right. What happened there? That is not the mid-plane. But that part is looking much, much better. Need to fix up that internal section. What's the depth of that now? That is 7.8. How did that get there? So this bit. Let's just go back to the very first contour, do an extrude cut, select the in face and just go up to surface. And that will do. Very nice. This part is black. Let me just update the name. We'll add a material. Put it into our group with everything else. And that is another one. Done. Really good progress today. I think we'll wrap it up there. To my 2 current viewers, thank you for stopping by. Hope you might have got some insights from that. I'm looking forward to editing this when we get to that endpoint. I think the edit will be a much more efficient kind of lesson and learning process, but yeah, this is a different experiment, so giving it a shot. In the next lesson, we'll do parts that we haven't done, the other ones. We will look at more of those Lego type parts. So look at all of these ones over here on the left and get into the wheels. So we've done all of the smaller ones now. We've done that. We've done that. Done that. We've done that one. So we made some great progress. Let me check them off. I think that was this one, 5. No. Cheers, Hugo. 30552. Where's that one? Hinge Cylinder. I think it's this one. Yep, we've done that one. Why does it have that number? Five, 3, 9, 2, 3. Tick that off. What else do we tick off? This gear worm. Three, 2905. We did that one. That gear. All right, I think we're good from there. All right, signing off. Good night, YouTube.